Hey guys, this is episode 1. Thank you for watching. I appreciate it. Leave any comments after the video. If you got any questions please leave them. I will definitely answer them. But here we go. In this episode, we're going to be talking about some very important topics here. One being the anti-static wrap. Wristband, and also static electricity in general, and also we're going to be talking about the ground plane and the mounting holes on the motherboard. So those are 3 topics we're going to be talking about, and they're very important. In my demonstration, I'm going to be using the motherboard for demonstration purposes, but at this point you don't want to do not get out your motherboard just yet. There's no need for it at this point. Let's get the basics down. These are important topics to understand first, and then we'll move on. Okay? All right. So here we go. Okay. The first part I want to quickly talk about static electricity, and it's I personally have never had any trouble with it, but I think static electricity is something. From the research that I have done on it, it's something that actually doesn't necessarily have to make a component on a motherboard fail completely and making it obvious that there was damage, but it could actually just weaken it and make it not work as the way it should. So that's the possibility there. So I always do just in case, just to make sure this doesn't happen. I always protect myself from, protect the motherboard from static electricity. Now, a little bit about the static electricity. Everybody knows, they've dealt with static electricity. You rub your feet on with your socks on carpet, then you touch a doorknob, and you get that zap, that arc. Now, that required, to get that arc across, that didn't have much amperage with it, but it had a lot of voltage. Okay, that's why it didn't kill you. Now, to actually get that arc, you need somewhere between 10 and 15,000 volts just to get that arc going from the doorknob to your finger. Okay, you don't need necessarily to have that much voltage to actually do damage to a computer motherboard. You need somewhere, I think I read, about 2,000 volts. So that's not enough to cause an arc. So you won't actually see you won't actually see an arc if you do transfer 2,000 volts. After discharging, after you discharge the voltage, the potential voltage from your body, you can't walk around too much while you're assembling the computer or handling the PC, the motherboard. So. Okay, so that's the breakdown on static electricity. Okay, guys, the first part of this we're going to be talking about the anti-static wristband or ESD strap, otherwise known as the anti-static strap. Basically, what this is for. Okay, basically what this is for. This is alligator clip. This hooks to a ground. This hooks to a grounding point to discharge any potential, voltage potential that you have built up in static electricity surrounding your body. Okay, that's attached to a ground and discharges that to that ground. Okay, this part right here, this goes on your wrist, and it just fits over your hand, and just like that. Or you could probably put it up here too. I don't know. I got less hair on the bottom. You basically want the metal part here, to be touching your skin. At this point, you would then attach this to the ground that you want to discharge to, so your voltage potential is the same. Okay, so after you put on the strap on your wrist, what you want to do now is take the alligator clip and go ahead and touch the screw to eliminate any electrical potential you have built up on your system, on the outside of your body. At this point, after doing that, you don't want to move around too much. You want to go back to where you're working, and that's it. And then I'll show you how to discharge any else, and any other if you built up anything walking from here to the back to your workbench. So, okay, here we are, guys. Prior to handling the motherboard, you want to find the mounting holes that are on the motherboard. Now, these mounting holes serve two purposes. One is for a mounting spot to attach to the chassis, to the PC case, and also you'll notice that there's a metal ring around that, and what that's attached to, among a lot of controversy, if you go on the internet and just look up mounting holes and ground, this spot is actually grounded, is actually attached. A lot of people don't think it's attached to the PC circuit, to the board circuitry, but it is. It's attached to the ground plane of the board here. And what a ground plane is the common ground for all this circuitry, all the circuitry that is on the motherboard. So they all have a common, instead of running, multiple home run lines for every circuit here that's on the board here, they have one ground for all the circuits, and these attach to what they call ground plane. Ground plane also helps with RF interference. The bigger the better. Surface area, so it helps with loopback protection. So that's why so just to prove, so for us to work on this, what I'm going to do is I'm going to go ahead and touch the ground plane. Okay, so at this point there's zero potential voltage between me and the board, so I feel pretty safe about handling this board now. Of course, you always still want to handle it by the sides and not really lift it by any components. But when you do decide to, when you do ground yourself to the board finally, pick a mounting spot that's away from any ICs. Like, these are capacitors, and I chose this area because it's away from, pretty far away from any ICs or anything like that are on the board. So just pick a spot that's not so close to any of the integrated circuits, because those are the problem ones. You want to keep yourself attached to this board, so I'll show you how I would do that. First, we got the standoff here, this brass piece, and this is the motherboard machine screw. Now you notice it has a little flange around it. Okay, now this flange serves two dual purposes here. One is to, of course, keep it from. One is to have a good surface area for grounding, and the other is to keep the PC board from being over tightened and cracking. So this keeps you from not 100%, of course, but in most cases, if you tighten it too much, it won't crack the board, and that's what we're trying to avoid. That's what that's why that flange is so big on there. And also the flange is actually is smaller diameter than the ground point right here. You'll notice me touching this on occasion, just so I keep myself at zero. You'll notice that this the net diameter on the screw is less than diameter of this, and the reason for that is you do not want the ground to extend any further than this mounting hole. That's why you always, you never use any other screw, any other hardware other than the motherboard machine screws. You'll get other, excuse me, I gotta go in front of you. You'll get other screws with your case, but you never want to use them. Like, you don't want to use this one. Let me show you this one. See that one? It's huge. Never would use this one, because it extends past the mounting hole, which then could cause a short between ground and the rest of the circuitry or anything nearby, which would then fry your motherboard. So that's why we only ever use these motherboard mounting screws. Okay, so let me show you how I would actually do this. Go ahead and ground ourselves. Okay, so now that we're attached to the board, let me just demonstrate to you the now that we're attached to the board, and I feel pretty comfortable working with it without any problems. I'm going to show you. I'm going to debunk some of the internet myths going around right now about those mounting holes and what they're actually used for. Because to be honest, when I first started this, I wasn't 100%. I started talking about the mounting holes, but then I was like, wait a minute, I'm not. I just did it a certain way all these years, never had a problem. But I wanted to make sure that I was comfortable with telling you a certain way, and feel very confident that it was the right way. So here we go. Let me just show you. I'm just using a pair of probes, and I'm going to turn it to continuity testing on the voltmeter. So these grounds, the debate sometimes is whether these grounds are just structural or whether they're for something, or they're there to provide a ground to the chassis. Because technically you don't need to mount this board in a chassis to get it to work. You could just hook it up to a power supply, hook all your components up, and this could be sitting on this table working and without any problems. That's because your power supply provides ground. But what the additional grounding that happens when you put in a chassis is it's additional protection against RF interference and loopback, because your chassis then becomes another ground plane, right? Because you're attaching that ground plane to a bigger ground plane. Okay, and that's what I deduced from the research. Okay, there's a couple myths going around. There's some controversy, I should say, about what the mounting points are for, what their purpose is. And from what I've read and what I feel pretty comfortable with going on video is saying would be that the mounting points are for mounting and holding the motherboard firmly, and it gives it structure. There's structure, but they're also, because of this metal ring around this, they're also there to ground the ground plane, which these are connected to the ground plane of the circuit board to the chassis. This is the sound we're looking for. Okay, we'll use this power connection for the CPU fan as an example. Okay, there's the ground. Okay, that's what we're looking for right there. Okay, let's pick that power connection right there. Okay, so I'm going to go ahead and show you. This is another. I'm touching that the mounting circle, the metal part, and I'm going to show you. This is the 12 volt, the extra power supply that all motherboards need these days, other than the main power supply. I'll get the voltage for you. Okay, see that? So that's the ground. That's a ground pin. That's connected to the ground plane. Okay. Okay. Okay, that's not. That's, even though it beeped, it just has a lot of resistance. It was just a momentary. This thing. Okay, that shows you that that's power. That's a power pin. Even though it beeped a little bit, that's okay. That's a power. That's power right there. The ones that, how you know it's connected to the ground is when there's no resistance at all. Like that one's power too. If we go back, see that those stay on. That's no resistance, and that's directly connected to ground. Okay. So these. So these mounting holes are for are for mounting and also for grounding the chassis to the motherboard. Here's the mounting point. Okay. You notice it doesn't look the same, but you'll notice there's these little metal star pattern, hex pattern, something like that. And I'll show you that this is meant to go through, the ground connection is meant to go, the ground plane is meant to go through this PC board all the way through to the chassis. Sorry. Okay. And it stays on. With those two tests concluded, I think it definitely shows that the mounting point on a motherboard definitely serves two purposes. It's there for structure. It's there to, and also it's there as a mounting point, and also it's more importantly, it's there to ground the ground plane to the chassis via the standoffs and the screw. Okay, that is the red paper washer. Now, you would think you would put that right over the screw, right? Because that was the way I thought about it, because I worked on cars. But in this case, since we've already figured out that this is supposed to be grounded, this metal circle here is supposed to be grounded, you do not want to use these metal washers or these paper washers on the screw, because you don't. That's basically an insulator at that point. So I had to think about why would they supply these at all if this is that's supposed to be. And what I figured out was this. I can remember at one time the motherboards used to have mounting holes that didn't have that metal ring around them, this metal ring right here. So obviously those mounting holes are not supposed to be grounded to the chassis, but they most likely will still have solder points around them and everything else, and circuitry around them. So if you were using metal standoffs and metal screws using that type of standoff, then you would have to use these paper washers, two of them to be exact, to insulate so that you don't ground out any solder points that are on the board or anything else underneath the screw here to the chassis. So what these are for mount holes that are not supposed to be grounded. Okay, and those you can identify those mounting holes by if they lack a metal insert around, if they lack the metal around the mounting hole. But I have a feeling that that's gone and done anymore, because I'll tell you, this board I've got, and it's about 4 years old, it doesn't have one. All the holes were designed to be grounding holes, grounding mounting points. So there's two types of mounting points. There's going to be, depending on the board you get and how they design it, there's probably going to be two types of mounting point. One is going to be the ground type, which is the one with the metal insert. The other one will just be a hole going through the PC board. In that case, if you do use that one, I would try to avoid it if you can. Don't use that one. But definitely do not use metal standoffs and metal screws at that particular mount point. What I would use would be, go ahead and get yourself nylon standoffs and nylon mounting screws. That way there's no chance of it conducting any electricity. Okay? So that's what I would do for mounting holes that are not supposed to be grounded. Okay guys, that's it for this episode. Thanks for watching. This is very important. This episode is very important. It establishes a baseline so you understand the safety procedures you have to take when you're handling your board, your motherboard, when it's out of the chassis. Once it's in the chassis, it's a lot easier to discharge yourself, discharge the static electricity from your body, and I'll show you that later how that's done. But when it's out, it's a little more difficult, and you'll be actually, it's easier to put all your components, most of your components on the motherboard before you install it. And that's just the way that is. It's just much easier. So I'll show you how that's done. But remember, always, before handling your board, always ground yourself first to a screw on the electrical outlet, and then don't go too far. Of course, don't go too far, and then walk back to your workbench, and then go ahead and then ground yourself the point I showed you, the mounting point to the ground plane. At that point, and then of course use your strap to keep yourself constantly discharged and not worry about wrecking any components on your system. Okay, good info. I felt like there was good information in this video. Rewind it if you have to, but really let this sink in. And I will see you next Wednesday. All right, guys. See you later. That was Minx. She said hello. Or that was Jinx. Sorry.